this happens. All right, welcome back, 11.2. And we're going to start this section off with what is called deriving the quadratic formula. Some of you may recall the quadratic formula from your high school days or previous courses here at the college. But we begin this by starting off with the standard form of the quadratic equation in ax squared plus bx plus c equals 0. And from this, I'm going to begin by dividing everything by a. I showed you a problem earlier where we had a number for a other than 1 that we divided out. So basically this is following the same pattern, same idea. So after this, then this simplifies to be x squared, and that's going to be plus b over a x plus c over a. That equals 0. Okay, at this point now I want to I want to solve this by completing the square. If I complete the square, that means the c, the constant, has to go. So I'm going to subtract c over a from both sides. So now we have this x squared plus b over a x plus something that's going to equal negative c over a. Okay, and here, what am I going to put in this spot that is going to be make this a perfect square trinomial? So just like I did with numbers, I'm going to take the b over a, divide it by 2, and then square it as such here. Okay, I could do what's inside here. B over a divided by 2, this is going to equal b over 2a. And then I'm going to square that. B divided by a divided by 2 equals b divided by 2a. Or just multiply the 2 times the a. All right, then I've got it squared. All right, so that's going to give me b squared over 4a squared. And of course I've got to add that to this side as well. I add it to the left side, so I have to add it to the right side. So I'm going to rewrite that as b squared over 4a squared. Okay, so far so good. So here's where I did my work at, and when I write this out and when I factor this out now, it's going to look like this. It's going to look like, I'll write it out separately. My x's go here, both positive signs here, and when the value I put in here is going to be inside this set of parentheses here, where I squared it after simplifying it, of course. So this is going to be b over 2a, and this is b over 2a. And then I can just write this up as x plus b over 2a, and I can square it. This is a 2. And that's going to equal this on the right side. Now on the right side, the only thing I want to do is I want to flip this around. So I'm not going negative plus a positive. I want it to be a positive minus a number. So that's going to be, I'll write this part up first as b squared over 4a squared. And now it's going to be minus c over a. Just a little cleaner looking and easier to compute. Remember, this is a C. Okay. All right, let me scoot this down a little bit. And where are we here? So kind of going off on an angle. All right, so what I want to do here is, let's see, I want to subtract these two. So let's see, in order to do that, I'm going to level this off here. I've got to get my denominators the same. So I'm going to multiply top and bottom here by, let's see, I'm going to multiply the denominator by 4a, and then I'll multiply the numerator by 4a, the same thing. So I end up with something like 4a squared is my denominator, and the top is just going to be b squared minus what's c times a times 4 is the 4 how do you write that? 4ca or 4ac. Okay, so after that, this is where we're at. I'm going to rewrite it. X plus b over 2a, that's squared, and this is going to equal this b squared minus 4ac, and that's going to be all over 4a squared. Starting to take shape, starting to look like the quadratic formula. And now, as other problems, I'm going to take the square root of both sides. And this one here, let's see, I'm going to take the top and bottom like I've done previously. And so the left side is going to be x plus b over 2a. And that's going to equal, let's see, the square root of this numerator here, there's nothing I can do because it's, I don't have factors there to take a square root from. So I'm just going to leave it as such. But the denominator, I can take the square root of 4a squared, which is 2a. Okay, and lastly, and again, here's my square root, so I know I have to put a plus and minus in before that. So now I simply just have to get x isolated, so I'm going to subtract the b over 2a. So that's going to look like this. I'm going to subtract b over 2a, subtract b over 2a, and I'm going to have x equals this negative b over 2a goes first, and then the plus or minus square root of b squared minus 4ac, all divided by 2a. And if I want to clean this up a little bit, it would just look like x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And there's your quadratic formula. Okay, we derive that, and that's how it's done. And this is a wonderful test item. Okay. All right, let's move on. Okay, so here we've got comparison before we begin our exercises, which is here on the right. I've got the standard form of the quadratic equation. And you remember seeing the ax squared plus the bx plus the c. And these letters that represent numbers, the a, b, c, are the letters that are in the quadratic formula. And thus all we have to do is plug in these values and calculate what this number becomes using our math skills. So as related to our first example, You know, I see I've got 3 here, and you can jot this down to help you if you want. So this would be something to the tune of A equals 3, B equals 16, and C equals 5. You can do that. I mean, whatever helps you to get the correct answer. And then you bring along this formula with you, the negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And let that be your guide as you're going through this. All right, so as this example here, you know, we're careful with our negatives and, you know, all that going on, like we always are. So let's see, I'm going to have negative b, which is negative 16, plus or minus the square root of b squared, so that's 16 squared, and that's going to be what? Minus 4 times a, which is 3, times c, which is 5. And that's all going to be over 2 times 3. And then away we go. So some of these problems you'll be able, on my exam anyway, you'll be able to use your calculator for some, but there will be others that you have to do it manually. And there'll be nicer numbers, you know, so you're not going crazy with too many big numbers. I want you to be able to know how the operation works, more so than doing them. But nevertheless, let's go ahead and calculate this. So I'm going to start with this under the radical sign. So I've got over here I can do it, and it's going to be the square root of 16 squared is 256. And then I'm going to subtract this. What is this? 4 times 3 is 12 times 5 is 60. And 256 to minus 60 is 196, so it's the square root of 196, which equals 14. Kind of get that out of the way. That's the biggest obstacle there. So what have I got here? So I'm gonna rewrite this to be negative 16 plus or minus 14 now. All this turned out to be 14 as depicted over on the right side here. Okay, and that's all going to be over 6. So it looks like I'm going to have negative 16 plus 14 is negative 2. And that would be over 6. Negative 2 over 6 is simplifies to be negative 1 over 3. So that's one answer. And the next answer is going to be negative 16 minus 14, which is negative 30. That'll be over 6. And that'll get me negative 5, comma negative 5. So here's our solution set right there. Pretty nice way of doing it. All right, so that's how this works. You know, then you got negative numbers to deal with. So let's see if I can find one more to do. Hold on. Okay, here's another problem. And now again, nothing wrong with bringing this with you each and every time you do a problem. I kind of feel a little bit more secure doing this. There. Okay, you'll master that and memorize it, and you'll feel good about that. All right, so when I'm looking at this problem now, I've got ABC I'm looking for. So I know A here is 2. A equals 2. B equals negative 4 this time. You know, minus 4 is the sign of the number, so it's negative 4. And C is going to equal... Well, we got to be careful here because it's not in standard form yet. If I bring it over to the other side where it's equal to 0, C would equal negative 3. Okay, just to be sure, you want it in that standard form of ax squared plus bx plus c equals 0. All right, so we caught that. Okay, and now we can plug in our values now. So notice I've got negative b, so negative b is going to be negative 4. And that will be plus or minus this square root of b squared, and b is negative 4 squared, negative 4 squared, and this number will always be positive, by the way. I just throw that out at you, but we're just plugging in right now. Negative 4 squared, and then that's going to be minus 4 times a is 2, times c is negative 3. Okay? And that's all over 2 times 2. All right, so let's come over here and do our square root, and that'll help us out going the rest of the way. So the rest of the way here, I've got the square root of negative 4 squared is 16. And before I put my sign here, I've got negative times negative. That's positive now. So that's going to be, now let's see, I got negative 4 times negative 3 is 12. 12 times 2 is positive 24. Okay. And finally, I've got the square root, that this ends up being the square root of 40. And the square root of 40, I want to simplify this as well. So let's see, what is that going to be? 40 would be, let's say 40 here. I'll break it down to be 10 times 4. 10 breaks down to be 5 times 2. And 4 breaks down to be 2 times 2. So I've got, let's see, for every 2 I take 1 out. So a 2 will come out front, and I'm left with the inside of 5 times 2 is 10. So all this up top is going to be 2 root 10. Okay. So let's see what I've got here. I've got the first 4 here, negative 4. This is going to be positive 4. It'll be plus or minus this 2 root 10, which was from here. So I got 2 root 10, and that's all divided by 4. Okay, so next we got some simplifying to do. So choose your poison here. Either way, you can rewrite it. I think this may, or you can see it. This is 4 divided by 4 is 1. So you could write it up as 4 over 4, and that would be the plus or minus this 2 root 10 over 4. So I'm just writing it out separately, or if you can eyeball it, that would be a greater help to you. So 4 over 4 is 1, and this is going to be plus or minus 2 over 4 simplifies to be 1/2. So that's going to just end up being square root of 10 over 2. And that looks like your final answer here. Okay, remember to simplify that as much as possible. And you've got it. Same thing. Same thing as their answer. They have answers that are the same, written in a different form. I'm looking at my textbook. Okay. Okay, here is a interesting problem. Example 3, where we have fractions in the problem. And, I forgot my equals 0. All right, and what we don't like, a lot of times we don't like to, mess around with fractions, and we can avoid them at times, and this is the case. And we learned how to do this back in beginning algebra when we have fractions in our equations to eliminate the fractions. And that's probably what we want to do here. We could use the fractions to solve it using the quadratic formula, but we don't always have to. So in this case here, if I clear the fractions, I'm going to multiply everything by the LCD, and the LCD happens to be 4. Okay, so if I multiply everything by 4, or I'll say multiply this side by 4 and this side by 4, then I'm going to end up with m squared minus 4m plus 2 that equals 0. I just distributed the 4 across to all the terms and simplified. And now I've got my ABCs. So A equals 1, B equals negative 4, and C equals 2. Now I can use my quadratic formula to solve this equation. So let's see, I'll start over here. It's going to be negative B, which is negative negative 4, and plus or minus the square root of b squared, and that's negative 4 times negative 4, which is 16. I'll just do it as I go. I think you kind of got the idea. Negative b squared, and it's going to be minus 4 times a, which is 1, times c, which is 2. All over 2 times 1. All right, so let's go work the radical sign over here. So I've got the square root of 16, and what is this? Minus 8. So this equals the square root of 8, which simplifies to be 2 root 2. Okay, and see where we're at here. So now I'm going to have 4, negative negative 4, negative 1 times negative 4 is 4, plus or minus 2 root 2, and that's over 2. So this time I'll do it like so. I'll write 2 under the 4 and 2 under the 2 because I got some simplifying to do. So 4 divided by 2 is 2, and that's plus or minus. The 2's cancel out here because they're factors now, right? And I'm left with square root of 2. And ladies and gentlemen, that looks like my solution of 2 plus or minus the square root of 2. Okie doke. That's that. And now we'll talk a little bit about the discriminant and stop there. Okay, in our next objective, it's about using the discriminant, and it comes from our quadratic formula, and in the radicand, this b squared, I'm going to just take out the radicand of b squared minus 4ac. This is called the discriminant. And because this has a lot of value when we're doing some graphing, and which you'll do in college algebra, I'm sure, explore this a little bit more, so we're introducing it here. The value of the discriminant is it tells you the type of problems or type of solutions of the quadratic equation. So it can more or less discriminate among those possible number types for just using the discriminant. Okay, so for example, if I calculate a number out of here and it is a positive number, then that tells me that I'm going to have 2 real solutions. It tells me that ahead of time before I do anything else with the values. Okay, if I calculate this out and it is a negative number, and think about that, if it's a negative number, kind of like a negative square root, then you're talking about the I, in other words. So it's possible that you could have two non-real answers, two non-real solutions. Okay, again, so that's involving, if you have a -1, a negative number in the radical sign, you're going to get the I. The I is the imaginary numbers, and imaginary numbers are non-real numbers. So that's fairly sounding complex, but it's quite understandable. And then the third possibility here is if you calculate a number and it's 0. If it's 0, then that means you have one real answer, one real solution. Okay? And that's the positive you get out of this. This is what you get out of knowing the discriminant and the power of the discriminant. So here's a couple examples here that we'll do. And let's see, give me 1 second. Okay, and here it is, example 5. It says use the discriminant to determine the number and type of solutions of x squared plus 2x plus 1. And I'm bringing along the discriminant with me to help me answer this. So here I've got, and you could do the labeling again, A equals 1, B equals 2, and C equals 1. And plug it in. So then I'm going to have B squared, so that's going to be 2 squared minus 4 times A is 1 times 1 times C is 1. So I got 4 minus 4 times 1 times 1 is 4. 4 minus 4 equals 0. So that means I have one real solution. Okay, that's what we do with it. Uh-oh. All right, let's try another one here. So let's see. I'm gonna throw this one up here. This is example 6. And it is 3x squared. 3x squared plus 2 equals 0. All right, so if I go ahead and label this, let's see, A equals 3, B equals, well, I don't have a B here. So B must be 0. Then C equals 2. So now I've got B squared minus 4AC. That's a B, by the way. So it looks like I have 0 minus 4 times A, which is 3, times C, which is 2. It looks like I've got a negative number here. So I've got negative 24. So then that's telling me I have two complex but not real solutions. Two non-real solutions. Okay, and that's the way that works. So you get the idea. So that's it. So that's where we'll stop here for now. And until I see you again, farewell.